So we start by writing this in partial fractions, and 3 over 2 brackets will have to equal ax plus b all over 1 plus 2x squared plus c over 1 minus 2x. If we multiply 3 by the common denominator, then 3 equals ax plus b, and be careful here to use brackets, times 1 minus 2x plus c upon 1 plus 2x squared. So if we go through and equate the coefficients, and if we start with the x squared, we have 0 on the left. We then have ax times minus 2x, so minus 2a, and we have 2x squared times c, so plus 2c. If we then look at the x's, we have 0 on the left, and we will have a times 1 and minus 2b. And if we look at the constant, we have 3, which will have to equal b plus c. If we take the middle one, a equals 2b, and now let's solve the equation. So the first one becomes 0 equals minus 4b plus 2c, and if we take the last one and multiply it by 2, 6 equals 2b plus 2c, and subtracting those, minus 6 equals minus 6b, so b is 1. That means that a is 2 and c is also 2. So our partial fraction then becomes ax plus b plus c over 1 minus 2x. If we want to expand this, then we actually want to expand 2x plus 1 upon 1 plus 2x squared to the power minus 1 plus 2 upon 1 minus 2x to the power minus 1. If we start with 1 plus 2x squared to the power minus 1, that is 1 plus n x plus n minus 1, 2 factorial x squared, and I'm going to stop here because that gives me a power 4. So 1 minus 2x squared plus 4x to the power 4, and we need to multiply that by 2x plus 1. And if we multiply those together, we get 2x minus 4x cubed plus 8x to the power 5, which we're going to be able to ignore. And then we have 1 minus 2x squared plus 4x to the 4. So our expansion is 1 plus 2x minus 2x squared minus 4x cubed plus 4x to the 4. Now I repeat the expansion. We have 2 upon 1 plus 2x plus minus 1 minus 2, 2 factorial minus 2x squared plus minus 1 minus 2 minus 3, 3 factorial minus 2x cubed plus, we have to go to power 4. So that's going to give us 2 plus 4x plus 2 times 4x squared minus 2 times minus 8x cubed plus 2 times 16x to the 4. So 2 plus 4x plus 8x squared plus 16x cubed plus 32x to the 4. And if we bring the 2 together, we get the answer 3 plus 6x plus 6x squared plus 12x cubed plus 36x to the 4. If we have the expansion 1 plus x to the power minus 1, that is only valid for the modulus of x less than 1. So if we start with our first expression, and it will only be valid for the modulus of 2x squared is less than 1, which is when the modulus of x squared is less than a half. Whenever we are dealing with squares, I always draw a graph and a line. So we want where our two cutoff points, and they're going to be 1 over root 2 and minus 1 over root 2. We want less than a half. So minus 1 over root 2 is less than x is less than 1 over root 2. Our second is only valid for the modulus of 2x less than 1. I've ignored the minus sign because of the modulus, and that happens when the modulus of x is less than a half, or when x is in the range minus 1/2 to plus 1/2. And then if we combine those two ranges, then it is true for x from minus 1/2 to plus 1/2.